Okay, today we're going to talk about compound inequalities, which is just two inequalities put together to make one statement. For example, like number 1, where I have negative 3 is less than or equal to x is less than 2. And so I have two inequalities. So before I graph this, I'm going to break it up and rewrite it so I can see what my two inequalities are. I have this one, and I'm going to rewrite it so my x is on the left. It says negative 3 is less than or equal to x, which is the same thing as x is greater than or equal to negative 3. I just turned the whole thing around. And then I have this part of the inequality which says x is less than 2. So I also have x is less than 2. So when I graph this, I'm going to put my 0 on my graph. There's my 2 and there's my negative 3. We'll always start at the smallest one. So x is greater than or equal to negative 3. So that means I got to have a closed circle at negative 3. And then x is less than positive 2, which means I have to have an open circle at positive 2. Well, if x is greater than negative 3, then it extends this way to the right. If it is less than positive 2, it extends this way to the left. And so what happens is they meet right here in the middle, and so my graph ends up looking like this. And so the only numbers that are going to make that inequality true are all of the numbers from negative 3 up to but not including positive 2. So any number that is in between this little section right here is going to make that inequality true. Every other number does not work. So let's try the next one. So we're going to break it up again. I have 3 is less than x, which is the same thing as x is greater than 3. And I have x is less than or equal to positive 6. So we're going to graph it. I have my 0, there's 3, and there's 6. Well, at 3, I have an open circle because it's just greater than. And at 6, I have a closed circle because it has the or equal to. It's greater than 3, but less than 6, so it's every number that just falls in between there. And if you look at how it's written, x is in between the 3 and the 6. So we want to make sure that our graph has the numbers in between 3 and 6. So number 3 and 4 ask us to write the compound inequality. So we're going to look at what we have here. Let's label our number line. This is negative 4, and this is positive 3. And when I do this, I always start with the smallest one. So we have the negative 4. And it has an open circle, so I know it doesn't have an or equal to sign. And the line from negative 4 extends to the right, which means greater than. So I know that x has to be greater than negative 4. Now this one over here, the 3, it's also an open circle, so no equal sign. But the line from it extends to the left, which means less than. So I have these two things. I have x is greater than negative 4 and less than 3. But I want to be able to write it like number 1 and number 2 were written up here so that they are together. So here's how I do that. I go from least to greatest, so I have my negative 4 and my 3, and x has to be in between them. And so let's start with to put our symbols in, we'll start with this side first because that's the one that's going to be written in the correct position. So I have right here x is less than 3. So I'm going to put my less than symbol right here. This symbol that goes right here must face the same direction as this symbol. So I go back to what I originally wrote, the x is greater than negative 4, but in order to write it in this between statement, I have to turn it around so that they face the same direction. So let's do number 4. Let's label our graph. I have negative 1 and 4.5. So I'm going from negative 1 to 4.5 with my x in the middle. Now the 4.5 has a closed circle, which means it's going to have the or equal to part. Excuse me. And the line extends to the left from there, which means less than. And then for the negative 1, I have an open circle, so no or equal to little line, and my line extends the other way. And so make sure my symbols face the same direction, and there we go. So now we're going to solve them. When you solve a compound inequality, it's just like solving a multi-step equation. The only difference is when you are solving it, you have to make sure, because you have 3 parts happening here, you have to make sure that everything you do happens in the middle. Sorry, I erased something. It happens in the middle here, and then it happens on the left and on the right. So everything we do, we have to put here, here, and here. So the first thing we're going to have to do to get that x by itself is we're going to subtract 3. So it cancels out here, but then I have to subtract 3 over here and from over here. So we have to be fair with everybody. So negative 5 minus 3 makes negative 8. Then I have less than or equal to 2x. And then that's less than or less than 9 minus 3 makes 6. So that's my first step. Now second step, I've got to divide by 2, which means I have to divide by 2 here and here. And so what you end up with is negative 4 is less than or equal to x is less than 3. Because negative 8 divided by 2 is negative 4, and 6 divided by 2 is 3. So now we're going to graph it. So we're going to put our numbers. There's my 0, negative 4, and 3. So we'll start with the negative 4. It's going to have a closed circle because it has the less than or equal to. And 3 has an open circle. And since x is between them and my lines face the same direction, okay, it has to go to the left of 3 to make the less than, and then to the right of the negative 4 to make it go in between. And so there is my graph. So let's solve number 6. The first thing I want to do is get rid of that being divided by 4. So I'm going to multiply this entire thing by 4. When I multiply by 4 in the middle, the 4's will cancel. But then I have to multiply by 4 out here on the right-hand side. Well, that makes 16 is less than or equal to 3x minus 2 is less than or equal to, and then 7 times 4 is 28. So now I have to solve this. So I'm going to add 2. But I have to add 2 here and here as well. So I have 18 is less than or equal to 3x is less than or equal to 30. Now I have to divide by 3 here, here, and here. Well, 18 divided by 3 is going to be 6. It's less than or equal to x. 30 divided by 3 is going to be 10. And so I have my symbol. So let's graph. I put my 0 and put it down far enough. So we're going to move it. So let's put our 0 way down here. There's my 6 and my 10. Well, they both have or equal to symbols, so I have to do a closed circle at 6 and a closed circle at 10, and x is in between them, so I have to connect them to make it in between. So there is my graph for that compound inequality. So let's look at number 7 here. Jimmy's car can travel between 380 and 410 miles inclusive, which means it includes those two numbers. I apologize if I am repeating this. I thought I recorded it and then I didn't, and so if I did and I didn't know it, I apologize. So he had a full tank of gas. He filled up his tank and then he drove 45 miles. We've got to know how many more miles he can drive without running out of gas. Well, here's what we know. How many miles can he still drive? Plus the 45 miles he's already driven is going to give us the total. We already have the total. Now, I know we need to subtract it, but remember, you're thinking in your head, I have to subtract that 45, but that's because that's what we're going to do to solve the problem, not how we're going to set up the equation. This is how many miles he has left. That's what that x represents. So the number of miles he has left plus the 45 he already drove will give me my totals. And this says that he can travel between these two amounts. So I have 380 and 410. Well, 410 is the maximum. So he cannot drive more than 410. So I get to put less than, and I put or equal to because of that word inclusive. This symbol must face the same direction, and it is also inclusive. And so there's my 380. So now in order to solve this, I'm going to treat it just like I did the ones on the other page. I'm going to subtract 45, which is what we all thought we had to do to begin with. Here, I have to subtract it here and here. And so 380 minus 45 happens to be 335. And then 410 minus 45 is 365. So what I know is that Jimmy can drive between 335 and 365 miles still before he runs out of gas. Okay, so there is that one. So let's do number 8. It's an average question, and I put it on here because we're still sort of struggling with these. So Jill wants to find her test average in her class. The scores she made on her tests are these scores. She made a 75, an 82, a 78, and an 85. We want to know what she has to make on the next test for her average to be between a 78 and an 80. She doesn't have a specific number. She just knows that a 78 to an 80 will be okay and her mom will not be angry. So we have a total of 1, 2, 3, 4, 5 scores. So I have to divide by 5. And we want it to be between a 78 and 80. Well, ask yourself this. Is a 78 acceptable? So is 78 an okay answer? If it is, then we can put the or equal to. Same with an 80. Is an 80 an acceptable grade for her average? I would think so. If it has to be between there, I would think that it needs to include it. So we're going to do less than or equal to 80, because 80 is her maximum. And then we'll put the 78 over here, because it always goes least to greatest. And then we're going to solve. First thing we got to do is get rid of that denominator of 5. So I'm going to multiply by 5. Left, right, and middle. When I do it in the middle, they cancel. What I do over here on the left, 78 times 5 is 390. So I have 390 is less than or equal to, and I'm going to go ahead and total up these numbers so I can get rid of that big long expression. I have 320 plus x, and that is less than or equal to, well, 80 times 5 is 400. And to finish solving this, I will subtract 320 from the middle, the right, and from the left. And so 390 minus 320 is going to be a 70. And then 400 minus 320 is going to be an 80. So her next test has to be any grade between a 70 and an 80, and she will still have an average that falls where she wants it. So that's what that means. So that is compound inequalities. I hope y'all have a good rest of your weekend, and I will see you on Monday.